The sun was humankind's first source of energy, and with a little work, it may be the only one we'll ever need. Good afternoon. My name is Michael Martin. A good desert collects more energy in 6 hours than the entire world uses in a year. The surface area of my body covers about 1.5 meters squared. If I were to lay out in the sun all day, every day for a year, I would collect about 1,500 watts of solar energy. Pretty much all of the power that we as humans use was originally solar power. Coal, now that's the fossilized remains of plants and animals that died eons ago and have been buried in the earth. And they got their power from the sun. Natural gas and oil, the same thing, the sun. Nuclear power, which produces about 20% of our energy needs, is one of the 2 sources that we have that isn't originally solar power, the other being tidal, which is created by the moon. Hydroelectric power. How does all that water get up into the mountains so that it has to run down the rivers? Well, it gets evaporated from the ocean by the sun. Wind power. As you may have guessed by now, all weather on our planet is created by the sun. Burning trees and corn husks and other biomass, as we do in biomass power plants, all of those organisms originally got their power from the sun. And then we have direct solar power, which naturally enough gets its energy from the sun and skips all of those middlemen. So it must be more efficient, right? Well, as it turns out, it is more efficient. And so you'd think being more efficient, it would be less expensive. Unfortunately, it is not. Generally, when we think about solar power, what we're thinking about are photovoltaic cells. Those big blue panels that people put on their roofs to generate electricity. Now, you may be surprised to learn we've known about the photoelectric effect for almost 200 years. It was discovered in 1839 by a 19-year-old kid named Edmund Becquerel. And his family is so interesting, we'll take a bit of a tangent. Edmund Becquerel was part of what we call a scientific dynasty. Edmund discovered the photoelectric effect. His father discovered that you can refine ores into their pure metals using electrolysis. And Edmund's son, along with Marie and Pierre Curie, discovered radioactivity. It's fascinating to me that there can be so much scientific talent, generation after generation, in one family. It's like Charlie and Martin Sheen, except with science, and with profound consequences. So, if you hit a wafer of polysilicon with light, some of the electrons on that silicon will get knocked off, and they'll be free electrons. It's something that's normal, but it's not anything like the sort of power that you'll need to create a solar panel. But what scientists and engineers figured out is that if you dope the silicon, and that's a technical term, it just means lacing it with impurities. If you dope the silicon with phosphorus, it suddenly has way too many electrons, and then we get what we call N-type silicon, N because it's negative. Then if you take another wafer of silicon and dope it with boron, that doesn't have enough electrons, and so you get P-type silicon for positive. A traditional solar panel is just a layer of N-type silicon sandwiched on top of a layer of P-type silicon, and then connected with a conductor, which we call a wire.